Good morning, grade 12 learners for physical sciences. The topic for today is on application of equilibrium principles. Start this topic by performing this experiment at home. Pour half a liter of water into a kettle. When it is about to boil, add cold water into the kettle. The moment you add cold water, you are disturbing a system in equilibrium. The following factors, concentration, temperature, and pressure, will be affected since they influence the equilibrium. Then the equilibrium will shift in such a way as to oppose or counteract the effect of change. These observed shifts in equilibrium are explained by Le Chartier's, called Le Chartier's principle. Le Chartier's principle states that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. Le Chartier's principle states that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. Now we have to consider how changes in concentration affect the equilibrium. Let me give you an example that you are familiar at home. A cooking samp plus beans is giving you umngqusho. If you add more samp, there will be less beans and more umngqusho. Don't use this example, it's just an example you are familiar with. Let's have a chemical reaction. Chemical A reacts with chemical B in order to form chemical C and chemical D, reversible reaction. If more of a chemical is added to the system, the concentration of A is increased. Some of A will react with B already present in the system, so the concentration of B decreases. At the same time, the concentrations of C and D will increase. A new equilibrium is established, and the rates of forward and reverse reaction again become equal, but with greater concentrations of products. The equilibrium has shifted towards the products or towards right. In a reversible chemical reaction, if one of the reactants is increased, the other one is decreased, more products are to be formed, and the equilibrium shifts towards the products. An example of Haber process reaction. 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas in order to have 2 moles of ammonia gas. If you increase nitrogen gas, you are decreasing hydrogen gas, but you are increasing the ammonia gas. Equilibrium shifts to the right, more products will be formed. Another example, let me refer you to the experiment you conducted during the first term on organic chemistry. 1 mole of ethanol reacts with 1 mole of ethanoic acid in order to have 1 mole of ethyl ethanoate plus 1 mole of water. Then if you increase ethanol, you are decreasing ethanoic acid, there'll be an increase in ethyl ethanoate in that particular ester. So that's why some of these esters smell more alcohol. Then let's look also at the changes in temperature. When increasing temperature in any reversible chemical reaction, the equilibrium shifts as to favor the endothermic reaction where energy is absorbed, and a decrease in temperature favors the exothermic reaction. Exothermic reaction is grade level where energy is released. Example in your textbook on endothermic reaction, Ustad and Master, page 217. When 2 moles of potassium chlorate, KClO3 in solid form, is heated to form 2 moles of potassium chloride in solid form plus 3 moles of oxygen gas. If temperature is increased to potassium chlorate will decrease. Potassium chloride increases and oxygen gas increases. Forward reaction is favored and more products will be formed. Another example, let's look example in exothermic reaction in your textbook. Example of Haber process reaction. In this particular one, Haber process reaction is an exothermic reaction because heat is given off. If the temperature is increased, nitrogen gas increases plus hydrogen gas increases, then ammonia decreases. The equilibrium will shift to the left. More reactants will be formed. Increase in temperature favors endothermic reaction. Decrease in temperature favors exothermic reaction where energy is released. How the equilibrium constant is affected by changes in pressure. We can also use that Haber process reaction on page 218. 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas, forming 2 moles of ammonia. The total volume for the reactants equals to 4, and the total volume for the products is equal to 2. When pressure is increased, equilibrium will shift so as to favor the side with less number of moles. The forward reaction has less number of moles, has got 2 moles of ammonia. Then the reverse reaction has 4 moles, of reactants. The pressure on the system is increased by decreasing the volume at constant temperature. The pressure on the system is increased by decreasing the volume at constant temperature. Let me emphasize the following. If you think of adding a catalyst has no effect on the equilibrium constant. A catalyst has no effect on the equilibrium constant. Kc, the equilibrium constant, will only change with a change in temperature. Kc will only change with a change in temperature. Kc equilibrium constant is temperature dependent. Only a change in temperature can alter the value of equilibrium constant. The catalyst only speeds up the reaction. A change in concentration or pressure may alter the equilibrium position, but it does not change the values of the equilibrium constant. In conclusion, let me start by recapping the previous 3 topics. Reversibility of reactions lead to the concept of chemical equilibrium. Reversibility of reactions lead to the concept of chemical equilibrium. Do as many problems for the calculation of equilibrium constant. Do as many problems for the calculation of equilibrium constant. Design the table applying different molar ratios to the number of moles reacted or produced. Design your own table applying different molar ratios to the number of moles reacted or produced. I taught you the downward table, but work out the upward table. If you are required to calculate the number of moles given at the equilibrium constant. I taught you the downward table, which was my topic 3, but work out the upward table if we are required to calculate the number of moles given the equilibrium constant. Finer details of this topic will be provided by the subject teacher. Work out as many examples as possible from previous question papers. Good luck.